But I'll stick to the human health area tonight. The image that is often portrayed, intentionally or unintentionally, about a biomass facility as a smoky bonfire it's incorrect. It's inaccurate. What we really want to do is make sure that we understand that these facilities can be done properly. This facility will be done properly. They can be engineered properly, and my evaluation is based on the output of that engineering, the emissions estimates, the measured emissions that come from facilities like this, and protection of public health. The facility has to be engineered properly, and any evaluation of it should be based on those engineering circumstances. So it isn't that biomass is one thing or another. It's what is the facility that's using biomass as a fuel, and what are those emissions? That's the important question. As Bob mentioned, there was an extensive analysis done by the state of Georgia. There are requirements that have to be met by the state of Georgia in order to offer a permit or to grant a permit. Those have to be met by the facility. The facility can't take a permit and then just simply bust the limits. It's not an option that they have available, and they can't do that. The facility has multiple overlapping controls which deal with the different kinds of emissions: NOx, sulfur dioxide, particulates, and I'll mention a couple of others that I know have come up by a number of questions that people have raised over the intervening time period. Start with mercury. Mercury is one that gets people's attention. There are facilities that have, in the past, emitted a lot of mercury. Some of them are power plants, some of them are not. But this facility will emit on the order of ounces per year of mercury, not pounds of mercury. Facilities like this that I've evaluated in the past, looking at the monitoring of those, have projected air concentrations and subsequently measured air concentrations that were very, very low. In most instances, they were as low as or lower than the ambient conditions that are a result of conditions that are unrelated to this facility. And I'll come back to that because that's true for a number of these other emissions as well. The maximum concentrations, and it's worth remembering this, the point of maximum impact is what we use as our point of comparison. It's not that the maximum concentration is present everywhere. Everything else is lower than that. But we use that conservative view of the situation to make our comparisons. In addition, the assumptions that are made in the modeling, the dispersion modeling or the modeling of these concentrations in the environment, are conservative as well. And so what we get is a multiple layered conservative view of things, which gives a public health person confidence that if those conditions are achieved, public health is protected. It's worth noting that the standards that were mentioned at the outset are the basis for working backwards to the permit limits. So the permit limits are established to protect public health as measured by the air quality criteria. Okay, so those air quality standards are based on protection of health, even sensitive subpopulations, whether they be people like myself who are lifelong asthmatics, or elderly folks, or children, or people who have particular health considerations. Those are built into the air quality standards. Mercury also is emitted in the form of what's called particulate or in the form of reactive gaseous mercury. Virtually none is emitted in the kind of mercury form that we normally concern ourselves with in the environment, which is methyl mercury or organic mercury. That's only formed after a source has released the mercury, it's deposited to the ground, it encounters the right kind of bacteria and the right set of conditions, and the methyl mercury is formed. So it's a multi-step process, which is not impossible but difficult to achieve in the environment. So we need to make sure that we understand that. That's why we don't see the kind of mercury impacts around facilities that we might expect if all of the mercury was deposited right there. I mentioned at the outset that facilities that I've evaluated and looked at the modeling for that are very much like this, actually larger than this, but biomass also, don't cause measurable emissions in the vicinity of the facility or regionally. Particulate matter came up a few minutes ago, PM 2.5 particularly, and I'll focus my attention on that particular size fraction of the particulates. PM 2.5 and smaller incorporates or includes those what are often called microparticles or nanoparticles. So particles, when you hear PM 2.5, it's PM 2.5 and smaller. So that's what I'll limit my comments to tonight. The maximum concentrations will be well below the air quality standard. In this instance, for an annual average, it's 15 micrograms PM2.5 per cubic meter of air. The concentrations, as Bob McCann mentioned, are 1% of the standard. So that would take, and let me give you Lowndes County or Valdosta as an example. The air quality here is good. Particulate numbers, depending upon the time of year, particulate circumstances, are 9 to 11 micrograms per cubic meter. 9 to 11 micrograms per cubic meter with the contribution of this facility will be somewhere less than 9.1 or less than 11.1. So it's a negligible contribution. It's not zero, but it has no effect on human health.
Excuse me.
No.
You'll forgive me.
You can't. I don't.
I just wanted to compare it with the forest fire we just had.
Sure, it'll be absolutely nothing like that. That was way worse than anything that will ever be associated with this facility. Not even a bit comparable. Not even close. Sorry? The other point to make is that at facilities like this, biomass facilities of a similar size, although they were larger, the comparison between an equivalent mass of material burned in the facility versus burned in the environment, in a forest fire or a prescribed burn, for example, reduces the mass of particulates by orders of magnitude, by thousands of times, okay, by tons per year. So if only you compared the same exact amount of material burned in the facility versus outside the facility, you'd have a tremendous advantage. Another substance that comes up in these kinds of discussions is dioxins. Now, dioxins are formed by any combustion process that has in the presence, it also has the presence of chlorine. It can be trash burning in the backyard. It can be fireplaces. It can be coal-fired utilities. It could be cement kilns. It can be medical waste facilities. All of those contribute to the dioxin load. Now, in the past 25 years, EPA recognizes the fact that the controls that have been placed on dioxin emissions of all kinds have reduced dioxin emissions by about 92%. At the same time, over the same time period, dioxin body burdens in the human population in the United States have decreased by about 80%. The kinds of controls that have been placed on facilities like this facility are working. They'll continue to work. They should be employed. They should be used on facilities like this, and they are. And the word is, the conclusion is that they work. The same comparison I gave to you just a moment ago about particulates, the side-by-side comparison of the same mass of material burned in the field versus in a facility like this reduces the concentration and the amount released by grams per year. Now, as a point of comparison, the facility at a point of maximum impact is going to emit roughly a tenth of a gram of dioxins per year, okay? Not burning this amount of material in the field reduces that by about 5 to 9 grams, depending upon the amount. So there's an absolute benefit to doing that. The controls result in these extremely low concentrations and masses being emitted. One of the other substances that gets emitted from facilities of all types that are combustion are polycyclic aromatic hydrocarbons, PAHs. They're formed from all kinds of combustion, trash, utility boilers, variety of different vehicle emissions. The wiregrass emissions are very low, very, very low for any facility of any type. And it's, again, because of the engineering and the controls that have been placed on it that layer upon one another to reduce the emissions. Now, the word aromatic in here, from time to time, someone will say, does that mean it will smell? Is it going to be aromatic? Aromatic in this context refers to the ring structure. Polycyclic aromatic means there's more than one ring in it. Most of these substances are not aromatic, and most of them are very low volatility. So they're not aromatic, they don't smell. Most of the exposure we get to PAHs is from lifestyle. It's from the food that we eat, grilled foods. It's from cigarette smoking or secondhand smoke that we may get exposed to. It's from our vehicles as we drive them or as we're near roadways. So yes, it's true these things should be controlled. There are ongoing effects that are caused by them, and facilities like this have the controls that they have on them because of our concern. It's not a misplaced concern. It's a concern that is being dealt with by the engineering. So from three of us now in a row, and you may hear it from others, the permit limits and the engineering controls on the facility have been set on purpose to limit the emissions. Again, your thoughts and your concerns are not misplaced. The importance should be placed on what are the limits and what are the emissions, not that there will be some emissions. Okay? Comparisons are important, and in this instance, comparing to health criteria and established air quality standards is a way to look at that. Emissions are low. We don't expect any odors from this facility, and it represents a valuable addition to what I think you're going to hear later is an essential mix of fuel sources. We're not going to power the United States with coal. We're not going to power it with natural gas. We're not going to power it with solar. We're not going to power it with biomass. We're not going to power it with nuclear. We're going to power it with some combination of those in the appropriate mix with the appropriate controls to protect public health. Thank you.